Hi there, it's me again with my vapes. I thought I'd given up with these, but having found one at the side of the road with the blue light flashing on the end, I decided I needed to reinvestigate, to go in deeper, to examine it in more detail. I'm not finding as many as I used to, fortunately. I assume that's because they're recycled and not because people are giving up with them. Unfortunately, I seem to see more and more children with these things, which is a bit upsetting to me, but not surprising when one looks at what they're actually selling them as. Cherry cola. Yeah, right. Anyway, so I want to look at the electronics behind it. To do that, I need to take it apart. I've loosened the ends so that hopefully it will just come off. Maybe not. Maybe I'll have to use a screwdriver on it, see if we can get that in. Probably end up shoving it into my finger, so I need to be careful. They are quite tight, these. I assume they're not designed to come apart. This one certainly is hard. Oops, that was almost in my finger. Keep turning. See if I can get it. There it is, we've got him. The other end then, oh, that comes off easy, and therefore I can push out the innards of this thing, hopefully. Well, there's the cell there, and then there's the heater in the nasty chemicals. I'm not very happy with these chemicals around. They tend to stink the place out, so I'll put it straight away into a polythene bag, keeping the chemicals at bay, hopefully. So that now's in its polythene bag. What have we got then? If we look, we've got this device at the end holding the chemicals here with a heater on the inside. We have the cell. The blue wire from the heater comes from the sensor at this end, and there's the sensor, there's the cell, and there's the heating element. What I want to do then is to take it apart so that I can take some measurements from it. To do that, I cut it here and here, and then put in a socket. And in good blue Peter sort of thing. Here's one I did earlier. So I've got my chemicals in here, and then I've put a plug and socket on here so that I can disconnect the chemicals, and at the other end I've put a socket on here so that I can disconnect the cell or the battery. Why have I done that? Well, the idea is to be able to measure current in and current out, and the voltage in and the voltage out. So if we set this up, then what we want to do is to set up the first, will that go there? First voltmeter, first ammeter. This is an ammeter then, and we'll set that to 10 amps. The next one we've got is a voltmeter. Set that to 20 volts, and we put that onto there, and we missed, so try again. That's there then. That shows me that my cell has actually got 4.07 volts on it. We're getting no current at the moment. It's on the 10 amp scale, so it isn't measuring anything. Plug in the sensor. So I plug that into there, and that's the sensor in, so no current still, and put the output in, getting it the right way round. So that gives me my output. Turn this then to 20 volts. I'm not getting the output at the moment because nothing's happening. I then want it to go into my next ammeter here, so that's this one. I've plugged it in, switched the ammeter on. Once again, 10 amps scale. and then it comes out from the ammeter, so that I can charge and discharge it. I've put a changeover switch on the output, so we have our changeover switch here, and at the moment I want to plug in an output. I don't want to use the chemical things, these, so what I've done is to take the heater out and put it into some water. So there's the heater, just in water, so that hopefully it ain't gonna burn out. I then need to connect that onto my changeover switch, plug that in there. Hopefully that's in. Being a heater, it shouldn't really matter which way around it is. As far as I can work out, it's just a bit of nichrome wire. Right, so we're all set up. What next? What do we want to do now? Take my capacitor lead out of the way. That might be a bit confusing at the moment, so that's not involved, that's for later. Right, so we've got an ammeter, voltmeter, IC chip sensor, voltmeter and ammeter on the output. Nothing's happening. How can I get something to happen? Well, if I blow into, now of course I'm blowing in rather than sucking on the other side, or reducing the air pressure on the other side to get this to work. So I'll just try that. Let's see if I blow. And hopefully we could see that there are about 2.99 volts on this, that this was going about 2 amps, and therefore if we add 3 and 2, 3 times 2 is 6, so we're sort of looking at 6 watts. Try again. You'll notice that the voltage on the battery goes right down, but that it does in fact work and it does come out. While I'm on with this, I suppose I ought to look at what current is actually being drawn by this cell without any load on it. So if I take it down to the microvolt scale, I see that it is consuming about 6 or 7 microvolts when nothing is going on. So that means the cell's going to last an awful long time. Can't be bothered with the calculations, but if it's a 1500 milliamp hour cell, it's going to last a long time at that. Put that back onto the 10 amps. Blowing into this thing's a bit tedious, so I'm going to not use one that I need to blow into. But what I have done is to prepare another one here. Actually, this one is still a complete sensor. I haven't taken the aluminium casing off it, so that won't be any advantage to me. So what I'm going to do is to get one where I've taken the case off, taken the aluminium case off, and all I'm left with, if we can see it, is the circuit board there. You can see the chip. Just look at the size of that chip, and that is handling 2 amps. Wow, never thought I'd see such a thing. Anyway, that's the PCB with the chip on it. There's the wires connected at the other side. But what I've also connected are 2 wires on, one to the sensor and one to the 0 volts. Perhaps it'd be better if we looked at a picture of this now. So if we have a look, a picture's easier to see. What we've got then is the chip here, and just across the end of a chip there's a little capacitor. So it shows that these people are caring about what they're doing. Here's that same circuit board, but with the chip and capacitor removed. we can see that the ring round the outside actually connects to the pin 1, which is the sense input. Pin 2 is the 0 volts. Pin 3 goes across here on this sort of greeny line, and that goes through to the other side of the circuit board where the LEDs are arranged. Pin 4 then is the output, that is what switches the heater on, and pin 5 here is the power supply from the battery or cell. So yeah, we have this line round the inside of copper which connects to the input, but on the other side of the circuit board we have a line round the outside, or a track round the outside, and that actually, this outside one here, connects onto the PCB there. If we look at what the components are then of this particular sensor, what we've got is, number 1 is a waterproof net. That's just the bit of fabric that seems to be stuck over the top of it. We then have the aluminium casing. Then we have what's called a polar plate. So if we look here at a cross section, we have the case on the outside, the polar plate here. We then have a plastic washer, that's this red one here that they call the spacer. Then a plastic ring which goes round the just inside the case, and inside that we have got what they call a film ring. This is essentially a piece of tubing, metal tubing, which is the sides here and here, and then across the top is stretched the piece of plastic film. This metal ring then sort of contacts with the circuit board on this ring on the inside, so it connects to the sense pin 1. And somehow this thing changes its capacitance when air is forced in at the top. So that's essentially how the sensor works. Here's a little circuit diagram of it. One, it shows as a mechanical switch, but I'm pretty certain it's not. It's a capacitor. We have the ground on pin 2, the LED on pin 3, the out to the heater on pin 4, and the power, the positive voltage on pin 5. So how was this going to work? Well, let's replace the one that we had before with this, just with this bare PCB. That goes in there, and hopefully that's in there, and then hopefully, where have I gone? I've lost my power, I've lost my volts, I've got no voltage left. Oh, I haven't connected that back to the 10 volts. Need that back, 10 amps, sorry, 10 amps here. So therefore that's giving me that there. And now what I find is, all I have to do is to bring my hand close to this blue wire. It's actually got insulation on it, so it's nothing to do with conduction. Just bringing it close, may even be able to get away with not actually touching it, getting close enough. Yeah, I'm not quite touching it, but it's not quite coming on. To show that it is actually a capacitor, I've got here a variable capacitor. It's about 7 picofarads when it's off. Now if I touch that, of course it brings on, I am enough of me connected to that to bring it on, and there it is going away. And if I connect the other side, now the capacitance is down to about 7 picofarads. But if I turn this round, hopefully, have I done it correctly? No, I haven't got it quite right. Oh, there we are. So there it's off, and there. No? Come on, you can do it. Have I lost? That's not quite in, is it? Is that what it is? Try again. No, that should be going. You can hear the water actually boiling. Ah, there we are. That's working now. Got good contacts. So when I increase the from 7 to about 40 picofarads capacitance, nope, it's not going to play again. Got a loose connection somewhere, I think. There it's working, and there it isn't. There it works, and there it doesn't. So once I can get a good connection between my capacitor, then I can show that all that turns this on is using the variable capacitor up to, I think it's about 40 picofarads. This is given in some of the circuits, some of the information, talking about, I don't quite understand why it's percentage at this end, but it says that we know it can be 0 to 12 to 20 picofarad, and it won't work, but above 20 to 40 then it does seem to work. So that shows me, to my satisfaction anyway, that this is capacitor controlled. So I can move that and take it away. So that's where I've got to. I found then that I've got, when I blew onto the other one, or I touched this one, what's happened? I've still got 4 volts. Something's gone wrong. Oh, there, got a loose connection somewhere, but I'm getting about 3 volts, 3 volts, 2 amps, which is 6 watts, and if I divide 3 volts by 2 amps, I get 1.5 ohms. So the resistance of this coil I calculate to be about 1.5 ohms. We'll notice that the cell itself is actually really knocked and goes down from its 4 volts to about 3.5. So it really is hammering that cell. Right then, so that's how it does. Now I want to look at charging, using this little chip to charge something with. So to do that, oh no, what am I going to do? I won't do charging yet. I'll have changed this over, and I will, instead of using the heating coil, I'm going to put in a light bulb. So if I lose a little torch bulb, shove that in there, will it go in there? Now of course if I turn it on, I can see the voltage doesn't go down as far, and I'm only getting about 50 milliamps, is it, of current to light the torch bulb. So this also shows me something else, that if I leave this on for longer than about 10 seconds, then it will actually go off. It'll shut itself down, will this chip, and it'll start, it flashed there, I don't know if you noticed, to say it had been on. If I come back again, of course, it comes straight back on again. It has no sort of off time. So why have I done that? Well, I've done that because I want to show charging and discharging, and to do that, instead of using a cell on the end, I'm going to use a capacitor. I think that's the main reason I'm doing this, because I've had these capacitors for donkey's years and I've wanted to do something with them, and therefore this seems like a good idea. Each one of these is around 100,000 microfarads or 100 millifarads. They're connected in parallel, so that gives me about 300 microfarads. We can see at the moment then they're up at about 2.5 volts, and if I were to charge them, let's see if we can charge them. to do that, I'm going to put 5 volts in on my slide switch. So if I bring my power across, give me the power, and put that in to here, get sure I get it the right way around. Yeah, that's positive, and connect it that way. Then nothing happens because of course my slide switch is set for this to be an output. But if I connect it the other way around, then we see we get a negative current flowing through this ammeter. In other words, it's going that way. I've got about 5.08 volts coming in, and if you noticed, the capacitors have charged up to about 4.18 volts. Of course, these meters are not going to be to a 100th of a volt or anything like that, but they show enough for what I want to see. So there we have it. We can see then that we've charged this up and it is now charged. So if I go back the opposite way, so that we're taking the current from the charged capacitors through the voltmeter to these 2 meters to the bulb. Once again, if I touch here, you can see that it lights the bulb, and the bulb stays light for a reasonable amount of time. Of course, my capacitors are discharging quite quickly, so I've only 3.4 volts on it. If I discharge it even more, then it goes down to about 3.2, and if I charge it just a touch more, or discharge them a touch more, come on, we'll notice now that it's gone down below 3.2, and when I touch it, it doesn't give me an output, but it flashes blue. And that's what I must have seen at the side of the road on the vape I picked up. So yeah, as long as it's below 3.2 volts, it gives me no output, but flashes blue. I can recharge it again by sliding my slide switch across. Charged up the capacitors again, once to 4.18 again. Still got the 5 volts from my power supply coming in, but no current coming in now, or at least it's not registering. Change it over again. Little flash to show that it's lost its power. Still stays at about 4.15. And if I touch it, then it lights the bulb for a reasonable amount of time until the voltage gets down below 3.2, when this starts flashing, showing me that it's below that voltage. So what have I shown? I've shown that I can use this to charge something with, and I can use it to discharge, and this will cut off and just flash blue when the voltage is below the 3.2 volts. I can also charge my cell, of course, if I take this apart, put the cell back on, then turn it on to power. Then now it's charging the cell. It's got it to, well, it's only charging it at 200 milliamps or 210 milliamps, so it's only charging it slowly. It'll take a long time for that to get up to the 4.2 volts. And we can see that the light's on here showing us that it is charging. So yeah, these chips can be used for charging and discharging. They take a very low quiescent current. They are operated by a capacitive device inside this little thing here. And so yeah, I think I managed to show everything I want. I don't think there's anything else I need to know about these chips. I think I can now put them away, forget about them, with the knowledge that I think I know everything about them. Well, as much as I want to know anyway. So, it's bye now. Bye. Bye.